Thank you. Good afternoon. Welcome to today's webinar. This is the fourth and final webinar in a series we've been running called Tidal Express. My name is Steve Wyatt. I'm the Director of Research and Innovation at the Offshore Renewable Energy Catapult. We are the UK's Technology Innovation Centre for Offshore Renewables. I'll introduce our panel in a moment, but before we start, I'd just like to say that our session today is being recorded, so people are able to access this content via YouTube after the event, and it will be emailed out to all of those of you who have registered. Please also remember that we have a Q&A box, and we encourage people who have tuned in to drop your questions and answers into that box. We'll be scanning that as we go through, and I'll put those questions to the audience. Throughout the series, the Tidal Express, we've been really delighted to be able to talk to the UK's leading innovators in tidal streaming technology. And today I'm really pleased to have brought some of those back together again to have this panel debate. So let us now meet our panel. I'm going to ask each of our panelists to introduce themselves and just say a few words about their role and company. So first, perhaps I can start with Elaine. Could you just introduce yourself, please?
Good afternoon, I'm Eileen Linkletter from EMEC, the External Relationship Manager. EMEC, for anybody who might be new to us, is the only accredited wave and tidal test and demonstration centre in the world. We provide pre-consented and cost minimising test and demonstration facilities in major wave and tidal resources around Orkney. EMEC has hosted over the years 21 different wave and tidal technologies from 11 different countries. And there's been 34 different devices that we've tested. So we've learned a lot along the way, which I hope to share with you today.
That's brilliant. Thank you very much. And Philip, perhaps I can come to you next.
Yeah, sure. So I'm Phillip Archer. I'm the head of product application at CIMIC Atlantis Energy. My role in the company has developed over time. I've been here with Atlantis now for 10 years. Started off in the loads department. I now manage that department. We also, in my department, do the resource assessments, site studies for our tidal sites. More recently, I've been working on directing the Japan project, which is a pilot project in Japan, which has been going on over the last year.
Thank you, Philip. And Andrew?
Good afternoon. I'm Andrew Scott. I'm the Chief Executive Officer at Orbital Marine Power. We're a Scottish-based engineering company that, over the course of nearly 15 years, actually have developed an innovative, very innovative tidal energy technology, which actually is a floating one. Through that 15-year development process, we were the first company in the world to grid connect a floating tidal turbine, which was a 250 kilowatt demonstrator, which we did at the EMEC facility. We then followed that up with a full-scale 2 megawatt prototype system in 2015, and recently, this year, we launched our commercial demonstrator, 2 megawatt O2 floating tidal turbine, which is the world's most powerful tidal turbine.
Thank you, Andrew. And John, finally.
Good afternoon. My name is John Marr, and I'm a Director of Business Development at Nova Innovation. Nova installed the world's first offshore tidal array in 2016, and it's been powering homes and businesses in Shetland for more than 5 years now. We're currently doubling the size of the array, making all sorts of headway and innovation there. And we've got a number of projects across Scotland, Wales, and we're starting our first project in Canada. So the first device is due to be in the water at the start of 2022.
John, thank you so much, and welcome to all our panelists. When we started this series of events back in November, there was huge hope and a lot of activity around the government's CFD. That's the contract for difference, the subsidy regime that provides launch aid for emerging technologies. And I guess it's been a bit of a roller coaster for us, because I think initially there was no dedicated pot of subsidy for tidal energy. And throughout the last couple of months, we've now reached a position where the industry have successfully negotiated with BEIS for a dedicated pot to support early tidal energy projects. So the ring-fence CFD for tidal energy, which of course is great news. And it feels like the government has sort of really fired the starting pistol on the first sort of commercial arrays that are supported through that same regime that things like offshore wind are supported at. I'd like to ask the panel, how significant is this development? Was this really that pivotal moment, or would things have carried on anyway? And perhaps I can direct that, John, at you first of all. You sort of said that you put the world's first tidal array in. So what difference is CFD going to make to your business and your project plans?
Thanks, Steve. No, it's a great announcement. So we've got a route to market through diesel displacement. So diesel in remote areas is very expensive, so we're competitive in that space. But what the CFD announcement does, it really turbocharges the development of tidal stream, and so it's really going to move tidal from the periphery to the core. So yeah, so it's fantastic news. It's a big step forward. It's not that we're going to be using this. There's going to be additional sources of revenue required as well. So it'd be fair to say that the CFD is more suited to sort of larger scale projects. And in Wales, they're talking about, the First Minister of Wales, Mark Drakeford, said they're looking to develop a Welsh Government form of revenue support alongside the CFD, recognising that complementary sources of revenue support will be needed.
So John, if I understand you right, are you saying that for smaller scale technology, it may be that the CFD is of course relevant and helpful, but you may need a sort of a top up or a dedicated support as well for sort of smaller projects? Or
Yeah. So CFD, great news, big step forward for the industry. But CFD traditionally is suited towards large offshore farms. Yeah. There is definitely an opportunity there for tidal. So that's what everyone's focused on at the moment. Yeah. But there will be, for smaller projects, there's going to be a requirement for a form of revenue support, which suits small projects, but also is more nimble. So to give you an example of that, we were awarded a contract in Canada 2 years ago, and it's the first turbines due in the water at the start of 2022. So you're looking at a 2-year period from being awarded to the device producing power. Under the current CFD, again, can't remember wrong, I believe the first power would be 2025, 2026. So you're looking at a longer lead time. So if the UK really wants to lead the world in tidal stream, as it currently does, we need a system which is going to just be a bit more nimble and agile to put devices in the water sooner.
Yeah, I see. I understand. Thank you, John. And Andrew, we've all been watching the progress of your technology as EMEC, and an amazing piece of kit, and feels like that sort of really is at an industrial scale. How is the CFD going to work for you, and what does that mean for your business and your project pipeline?
Yeah, well, I think it's been absent in the policy landscape for 5 or 6 years, and that's led to a real hiatus from an investment perspective. It's almost an impossible pitch to make if you don't have a market. So I think now, I mean, just as a signal alone that there is a policy out there for commercial scale tidal stream, I think it's a huge step forward, and hopefully we will see businesses and projects take off with investment flowing. That's ultimately what it should unlock. For us, absolutely, CFD is a mechanism that can work and we can make work for commercial scale projects. As I've said, we have scaled this technology. Our technology is a conceptual technology, so it scales up the way and down the way. We have scaled it to a point where we see the biggest market demand. There will be a lead-in of projects because we have just come out of a period where there hasn't been positive market signal. So that hiatus has created a shortfall in investment into technology companies, and it's created a blocker and a barrier to investment into projects as well. So I think for us, we see AR4 as hopefully the start of what will be a very exciting process. And we see more and larger projects hopefully to come through AR5 and beyond. So I think we're hopefully seeing that this is just the starting gun of what's going to be an industrialization process and a process of delivering tidal stream technologies at scale.
Yeah, and so I'm just sort of just getting a little bit that ramp up that's needed. Absolutely, we're going almost from a standing start because of this hiatus that you allude to. Is there a risk that projects aren't ready for AR4, or are there enough projects out there that are good to go, as it were?
There are projects that are available. Some of them are legacy projects from when the RO was still the driving force. Yes. Projects like Maygen and things that were established and invested in under the previous market mechanism model. Yep. They have consents there. And just recently, well, as recently as this morning, we just released the news that, but it wasn't really our news, is that the PTEC project off Isle of Wight has received all its consents, and indeed actually last week the Morlays project off Anglesey also received its consent. So there are projects able to react to AR4, and I think it's the responsibility of the sector now to deliver against that.
Yeah, thank you. And Philip, perhaps I can come to you. CIMEC Atlantis are obviously owners of Maygen, I think the world's biggest consented tidal site. What are the plans for that under the CFD?
Well, it's very exciting news for us with this CFD coming out, and I think as some of the other guys have said, we've been long overdue and really been anticipated really quite strongly by us that it will happen eventually. So we are, as it's kind of been put forward before, in a position to make use of this CFD. So we have had plans for a long time to expand on the Maygen project. Presently, it's 4 turbines, each of them is 1.5 megawatts, but the consents go way higher than that and will actually go further than this particular CFD will cover. So we're certainly in a good position to make use of this CFD, and we really look forward to putting a bid together for that.
Yeah, very good. And you've sort of publicly announced the tie-up with Nova Innovation. So do you see a sort of a mix of technologies being deployed at that site?
Yeah, I mean, that's not really my field, so I can't really comment too much on the way it's going to look moving forward. But certainly, we're very excited about collaborating and moving this industry forward as a partnership. I think but if we all go out on our own, we won't get very far. And so I think as an industry as a whole, we need to come together, and we are coming together. And that's one of the reasons I think why this particular CFD got through was because collaborations like the Nova and the Atlantis kind of happening. So I think it's a real positive. I think it gives us a great place to launch from.
Yeah, thank you for that. And perhaps it would be interesting to hear from EMEC's perspective as well. So Andrew sort of alluded to the fact that the importance of CFD isn't just the sort of the direct subsidy that can be channeled into a project, but it very, very much sends a clear market signal that creates confidence right through that technology development pipeline. So would EMEC expect to see more tidal developers coming in, almost a next generation of tidal, now being infused by the fact we've got a route to market again?
Yeah, I mean, this positive market signal has been a long time coming. So you used the word pivotal right at the start, and I would say it absolutely was pivotal. We've now got that really clear positive signal at UK level. What I would also say, though, is that I don't think that that's necessarily job done. We, speaking on behalf of the Marine Energy Council, are still very keen to push government further. So to make sure that BAEs are committed within their own policy to delivering, for example, a big ask is a gigawatt target in the 2030s, which is just another clear signal to incentivise investment, as we've seen in other sectors being really effective. So I think that's important, that we get BAEs in particular to get their shoulder behind this in terms of the delivery. And furthermore, I think it's been really positive, and John's already mentioned the fact that the Welsh Assembly are also coming in, and I think we are hopeful that the Scottish Government will similarly get behind this and help put some additional support in place to see these first projects away. And that would then help us get on that cost reduction trajectory, economies of scale trajectory, and really start to see things taking off. So there's still a little bit of work to be done, but the positive signal is absolutely there. And it's been very interesting, just that announcement, that 20 million announcement recently, we've had quite a few inquiries from an investment perspective of people just starting, their ears have pricked up in this sector. And that's really great to see.
Yeah, that's good. Do you think it's enough to put the, I remember sort of probably 5 or 6 years ago, the UK could proudly claim to be, absolutely world leader without question in tidal energy. And it feels like, developers have had to look overseas to overseas markets while there's been this hiatus in support. Is it enough to restate that claim that the UK is in pole position and leading the way in tidal energy once more?
Yeah, I think we've always been the technological leaders, and what was lacking was the market. And so now that we are starting to see that market take shape, I think we should have a bit of confidence in grasping that back. However, it's not a done deal, and I think there would be some nervousness that remains because other countries are really making great strides, and we'll come to this later in discussions, I'm sure, in terms of other parts of the world who are pushing hard in this sector as well.
Yeah, indeed, and I do want to pick up some points around the global market. Just before we do, it's impossible to resist drawing analogies with offshore wind and the tremendous cost reduction progress that offshore wind has made in the last decade. It's gone from something like £150 a megawatt hour, right down to sort of £50 a megawatt hour, just literally over the course of a decade. Phenomenal development. There's obviously an analogy with tidal there. I don't know the particular cost today, and perhaps developers would like to comment, but it's of the order of sort of £200 a megawatt hour or so. How long is it going to take to replicate that success? It feels like this ring fence pot isn't enough to get us there. So what do we need to come down that cost curve, and do we need to get all the way down, or is the energy system dynamic changed in the meantime, and actually we're not having to compete on least cost anymore? So I'll perhaps open that to the panel. Is there anyone who'd like to sort of offer some thoughts on that?
Yeah, I'm quite happy to start on this, but yeah, absolutely. I mean, the AR4 ring fence of 22 million, isn't it? I think that's going to cover tens of megawatts. The cost reduction that you talked about that offshore wind has achieved has been delivered across tens of gigawatts. So I mean, I think there should, and then that's part of hopefully a degree of comfort here, is that although prices are starting high, the administrative strike price asked was north of £200 a megawatt hour. We're not asking for that to be deployed against gigawatts of capacity. Tens of megawatts will get us down the cost curve. That's the way it works. It's a doubling of capacity. It's learning rates. So, but going back to what Eileen was saying, what if we want an industrial response here, and we want the industrial upside, is that needs to have a long-term vision on it. So we do need to see how we go from tens of megawatts to hundreds of megawatts, and ultimately we have gigawatts hopefully in the water, because it's across certainly those scales of tens and hundreds of megawatts. Yes, we'll see the cost reduction come down very sharply. And for an industry, I would say, our first touch point that we really want to try and be aiming for is convergence with nuclear as a low-cost carbon source that the government is prepared to contract at circa 90 to 100 pounds a megawatt hour. That is something that is achievable. We certainly think that's achievable within hundreds of megawatts. So I think that's goal number one, and doing that here in the UK will give a supply chain socioeconomic benefit, the likes of which the UK industry hasn't ever seen in the renewable space. So I think that's the other part of the delivery that we need to make sure we maintain here. It's not just a reduction in cost, but it's a magnification of supply chain opportunity and a growth of jobs in delivering technologies.
Yeah, thank you, Andrew. And perhaps I can bring John in at this point. So I mean, you've recently announced a major program looking at exactly this, sort of the intersection of cost reduction and UK/Scottish manufacturing. And can you tell us a little bit about how you're approaching that? Because clearly Tidal's got great credentials in terms of UK content. How are you going to maintain and potentially grow that UK content and come down the cost curve?
Well, thanks, Steve. It's a good point. I think you opened by saying, what are the learnings from wind? And we see huge parallels. So one of the key learnings was back in the 80s, there were some very large scale turbine devices which turned out to be commercial dead ends. And ultimately, the turbines which prevailed were those which started at the kilowatt and scaled up. So the strategy of starting small before scaling up is something that we've adopted at Nova, and it's served us very well. So we've built 3 turbines, which are deployed in 2016, 2017. That became the world's first offshore tidal array. We're currently doubling the capacity of that array. And last year, we installed our new generation of turbine, our direct drive. And that's more efficient, it's more reliable, you can go for longer without requiring a service. So there's an example of the innovation. And that's a core part of how we're bringing those costs down. And in our project in Shetland, it's done as the OnFair project. We're actually got a target there to reduce costs by 40%. And we're well on course to doing that. So that's one example. The second is economies of volume. So we can really bring down costs if we start to mass manufacture. And by winning turbine orders, like we have in Canada for 15 turbines, and we're hoping to win in more as we do more projects, we're really going to start to be able to mass manufacture and bring those costs down. So that's the second component. The third is economy of scale. So we currently have 100 kilowatt turbines. What we see is we can double those to 200 kilowatts and get bigger as the industry evolves and grows. So those 3 things together are really going to drive the business, drive those costs down.
Thanks, John. And I guess with your smaller units, at least initially, those early learnings, the doubling rate that Andrew talked about, you can benefit hugely from that, because of course 1 megawatt for you is what, 10 machines, something like that.
Exactly.
So yeah, and then potentially scale up in size, as you say, when the time is right.
Exactly.
Yeah.
Exactly. So it enables, the key thing is it enables you to manage the risk. So that's technical risk, environmental risk, and financial risk. The EU has set a target of reaching €100 per megawatt hour for Tidal by 2030, and we are well on track to achieving that.
Thank you. And one of the key areas for cost reduction for offshore wind has been sort of offshore operations, and whether that's O&M or initial installation. And Philip, perhaps I can bring you in here. At the Magen site, you've obviously got operational experience now from multiple turbine deployments and different technology variants. What are the learnings from that? And do you feel like you've learned quite a bit from the 4 machines you've got in to date, and how's that going to sort of scale up and extrapolate as you build out at Magen?
Yeah, sure. So I think our learnings actually started a little bit before Magen over at EMEC, actually, which is quite relevant to this call, with our AR1000 turbines, so one of our scaled down turbines. And it's very apparent to us that the success for our particular product was going to be dictated on how quickly we could get it in and out of the water, particularly in the water where we're looking at scaling up to large arrays. And so we've been developing technology which allows us to install turbines within 30 minutes. Thereby we can build out arrays very quickly, reduce our offshore costs, which is very important for us to keep the costs down. So offshore wise, I feel like we've probably installed and taken out more turbines than most. I think we're kind of self-proclaimed experts in that field. I think there's other things as well, but I think with this CFD, it's great for developing projects or a project, whichever way the government decides to go with the money. But I think it's touched on a little bit already, but innovation is also going to be key in bringing down the cost of energy towards the £100 per megawatt hour and lower. We've got a number of ideas about how that's going to be done for our technology, and so I think one of the things that it kind of needs to follow after this CFD is also funding for innovation. So I know that the European Union is looking into this at the moment already, and hopefully we'll win some grants to continue in our progress on the pitch system, our kind of powertrain design, and our electrical connectivity. There's a whole range of kind of savings that we know we can make, given the development time and given the funding.
Yeah, thanks for it. And Eileen, at EMEC, of course, you've been at this longer than anyone in a way. The Tidal site's been there for what, 10 years or so?
15.
Are there 15, crikey, yeah. And I guess there must be learnings. I know you've been deploying single devices, but of course you have an array, if you like, of different technology variants there. What are the key learnings that you've seen from your experience of these one-off devices that can, how can that translate to us coming down the cost curve? If you had some advice for the sector, if you like, about what not to do, or maybe what to do, what would it be?
Oh, wow. That has a myriad of detailed answers. Go to our website and look at all the different projects that we're involved with, everything from components to consenting and environmental monitoring. There's just a raft of collaborative work that we try and do to address lots of specific issues. But the big one really is what we advocate strongly for, is learning by doing. It's getting stuff into the water and working. It's only then that you really see how things work. And over the years, we've had people who've been very surprised how things have worked, or dare I say not worked. We've also seen some tiny components causing catastrophic failures. There's so many interesting stories along the way, but I just think that real sea experience is so important. We've been gathering a lot of information from single device deployments, and so now we do need to move to array deployments and what we need to learn from that as well.
Yeah, thank you. It's that classic story, isn't it, of the 10p fuse that costs £100,000 to change. And it's a bit of a cliche, but you've seen them at EMEC. And
the sea is just such an unforgiving environment. And the great thing is, I hope that what we've seen, and from what the other technology developers are saying here, is it's by that iterative learning and being able to take your learning and redeploy that into your design work is what gets you there. So I'm sure everybody will have their own stories to tell in that respect.
Yeah, I might volunteer Orbital's view on that, because obviously, as I said, we approached the whole challenge in a conceptually very different manner, and it was born out of an understanding of the operational constraints and challenges that come from working in the tidal stream site. We just talked about it there, about reliability of simple components. If there is one thing that we can still pull across from wind turbines, is they require maintenance and servicing. And so, what's key, what we recognize as key, is de-risking project economics from that uncertainty. So what you need is to ensure that the consequence of doing maintenance interventions minimizes costs and minimizes downtime. So, an interesting way to contextualize it is, for the O2, when the turbine's running at full power, it takes 40 minutes for it to generate the same revenue that covers the cost of the maintenance intervention. And we can press a button and then the cells come to the surface in a matter of minutes and cost minutes of generation to pay for. And that flows through, both from an operational perspective, even into construction ones, where our construction vessels cost us the same amount of revenue that we can generate in ones and twos of the tidal cycles. So that's ultimately, where we feel we've demonstrated a very different risk and cost profile for the sector, and something that we feel was very strongly validated by the strategic investment we just landed from Technip FMC, who are one of the world's largest installers and deliverer of offshore infrastructure.
Yeah, and delighted to see that investment. Congratulations on that.
You and I both.
Yeah, sure. And I guess just one follow-up question to that is you obviously got obvious benefits in terms of the operations and maintenance side of things with your O2 technology. Is there a trade-off in terms of more capital? So does it cost more to build the device, but you have a benefit at the tail end when you're operating it?
No, not at all. Not at all. I think it goes the other way. Steel is a fairly good proxy. So O2 was built with around about 250 tons heavy steel per megawatt installed. That actually compares fairly favorably to fixed offshore wind, certainly in the deeper water areas. So from a proxy perspective, that's a really good indicator. And as I said, from a manufacturing approach, ultimately, because everything is done in a factory style environment, we are minimizing the amount of construction activities, down to kind of anchor laying and chain laying, stuff that's very familiar with the offshore contracting sector. Is that we believe that we offer a very different construction cost profile. And actually, we're happy that, we actually quite open to talk about it, as a first of kind single unit using external supply chain, O2 cost installed around about £5 million a megawatt.
Nice.
We think that's totally different to what's been demonstrated before in this space. Yeah,
thank you. Good. I'm going to try and pick off a few questions in the chat here. I've been told that I've been a bit remiss in not doing this, so I'd like to try and do that. And the first question that's caught my eye here is taking us a little bit back to the cost reduction conversation, and it's saying, well, for offshore wind, one of the big cost drivers was going up in scale, so increasing the diameter of the swept area, if you like, of the turbine. For tidal, we've got obvious constraints of water depth, and we can't sort of scale indefinitely on that. And we've got a couple of different examples here. John, you've got small blades at the minute. Andrew, you've got two pretty big blades. How is it possible to scale? What do you think the maximum size of a tidal turbine unit is going to be? I think, perhaps you can tell us what diameters we're looking at the moment, Andrew, and where do you think it will get to? And then what do we do when we can't scale anymore?
Scale is absolutely a key driver, and wind's told us that through its development path. And just to give you an idea, so I guess, the SR2000, which is a 2 megawatt turbine, had 16 meter rotor diameters. The O2, which is a 2 megawatt turbine again, it actually has 20 meter rotor diameters. So that's a 50% increase on swept area. For effectively the same turbine, same amount of steel, same generator capacities, the yield is going to be probably about 50% more. So that gives you an idea about how significantly swept area helps in driving your levelized cost of energy downwards. And that's one of the reasons why, we didn't stop at 250 kilowatts that we grid connected a decade ago. We invested in scaling the technology. You've made a point. The sky is not the limit for us. We have seabed. So, to counter it as well is that, tidal stream is very locational specific. So there is a pressure in some ways to utilize that resource as best as possible. And that means trying to get in as big a swept area as possible within any given channel. And the reality is that tidal stream sites globally have different characteristics. So we see deep water sites, some sites, Penland Firth and things, have really deep water. So we expect rotor diameters to be able to grow and the capacity of turbines to be able to grow beyond the 2 megawatts that we're at, potentially above 3 megawatts or so forth. Rotor diameters, blade lengths, maybe, going from 10 meters up to 13, 14 meters, that kind of size of turbine. Equally, there are sites that are shallower and that will constrain turbines to smaller swept areas and ultimately smaller. So I think, there'll be similarities with what we see the wind industry generating, but I think tidal will generate its own landscape, and that will include, smaller swept areas and smaller capacities and larger turbines, depending on what sites you're looking at.
Yeah, thank you. Okay, so in short, Ian, who asked the question, thank you for your question. We've got some headroom yet in terms of size, and we might find that different sites lend themselves to different size turbines. Thank you, Andrew. I'm going to move us on a little bit. Estelle, you've been asking about the difficulties around planning and getting projects over the line. And perhaps, Philip, I can direct this one at you, and perhaps you can sort of, and perhaps move us on a little bit. I want to talk about global markets. Are there different experiences you can share between getting your project away at Maygen in the north of Scotland and some of the international projects you've been involved with? And how have you found it in different geographies?
Yeah, so Maygen, getting that off the ground was it was years in the making, I think. I wasn't directly involved in that. I'm kind of more involved in the technology side of things, but certainly years in the making. Environmental consulting, because it was the first of its kind, large scale tidal array. There was a lot of money spent on consulting and environmental studies, getting the right permissions in place, and so it was quite a long period of time, principally because it was the first. So it was the forerunner for what hopefully will come next in the next few years, which is more projects. I have been very involved in the Japan project, which is going on at the moment. We installed a turbine back in January, and it's going to finish its operation at this stage of the project in about 8 days on the 23rd of December. And for this one, we went through the same kind of process with regard to consenting and all the studies, but we had to encapsulate it in a much shorter time frame. So we had to get permission from the local fishing agencies. We had to do the hydrodynamic studies. We had to present data actually from Maygen on the impact on the environment. And that allowed us to push it through a lot quicker. And permissions were kind of garnered within the space of about a year. So from a year after the contract was signed, the turbine was kind of good, which is about to go into the water. And so, yeah, it is a challenge. There is still some unknowns. For instance, one of the unknowns would be, when you start to build out the arrays, for instance, like a Maygen, what's the impact? We've seen the very minimal impact of tidal turbines in small numbers. As you get to large numbers, what are the impacts going to be? Because that's going to be one of the outcomes of the hopefully Maygen expansion, will be kind of learning these lessons to help us with future consenting issues around the whole world.
Thanks, Philip. And Eileen, back to the trailblazing days of EMEC, when you really were trying to convince people that it was okay to put tidal turbines in the water. Any sort of challenges there that you sort of had to overcome?
What was interesting was, I think Scotland was quite trailblazing in that respect. And formerly, lots of responsibility for consents lay across a number of different sort of agencies within Scotland. And with the creation of Marine Scotland, they kind of brought that all together under one umbrella. And I mean, I think that's true of offshore consenting generally. And that was really helpful because they also adopted, where we were concerned, an acknowledgement that we were a test and demonstration site. And so they took what they called a deploy and monitor position. So we were granted consent, under the conditions that we had extensive monitoring in place. And we have done that. We've had long-term environmental monitoring projects across all of our sites, both baseline and continuing when different machines were interacting with that receiving environment. And all along the way, there's been, I think, a pretty healthy dialogue with the regulator here. What's interesting is that's been one of the most formative aspects of some of the international work we've done as well. So we knew that to create a global market, then there would need to be that groundwork done in other parts of the world. We created something called an International Waters Network, and it was just a network for sites like ours. So there's quite a few countries around the world who had similarly good resources and wanted to instigate an industry in their own shores. And so they kind of turned to what EMEC had done as a model. And so we've worked with a lot of different places. the collaborative approach to that, I think, is helpful in terms of being able to share some of our experience. Everywhere's different in terms of the environmental characteristics, but there are some approaches and some learning that can be shared to avoid duplicating effort and to expedite potentially what can be done in other places. I noticed one of the questions in the Q&A was related to Japan, actually, and the NEDO organisation. What's interesting there is, I think the question was more about, is EMEC like NEDO? Not really. NEDO would be more like Innovate UK or indeed the Catapult Network in terms of its role in technology and advising government in Japan. We're independent of that, but we actually did some consultancy for NEDO way back when they were trying to see what the potential in Japan might be. Which led to some site development in Nagasaki, for example, and hopefully was helpful in laying some of the groundwork for the Open Hydro and subsequently Simec Atlantis projects. So yeah, there's just a message in there in terms of collaboration, sharing learning with a view to creating that global market that we can then export into.
Yeah, brilliant, thank you. And just very quickly, I see we've got a question about fishing and interaction, and the question specifically about trawler nets, but anything around that? I mean, so I think EMEC were involved with some of the early conversations with the fishing communities and trawling zones potentially. How did we resolve that one, and is that still a live issue?
I think marine spatial planning was really the move to try and address that, again, led by Marine Scotland. On our site specifically, we very much avoided creating an exclusion zone and sort of opted to work with the local fishing community and make sure that sites were well marked for avoidance. And that has operated broadly well, bar one or two incidents perhaps. But I think just having that early dialogue amongst sea users is quite important. And yeah, having that global view in terms of the spatial planning more generally is helpful in setting out some of those parameters, like we've seen, you know, in Scotland or similar offshore consenting.
It's probably worth just saying on this point, tidal stream sites are incredibly hostile places. Generally you weren't, because of ground conditions and sea conditions, I'm not really aware of trawling activity that goes through. And additionally, you know, from a static gear perspective, generally, if you put static gear into a tidal site, it won't be there 6 hours later. So they're not as conflicted from that perspective as you might initially think. Yeah, indeed. Thanks, Andrew. Thank you. I just see, Max, you've asked about what is AR4? Is it technology readiness levels? Different things. So AR4, auction round 4, is the government's 4th auction for providing subsidy to emerging technologies in the renewable space or energy space. And technology readiness levels, as I think you probably know, just a gauge 1 to 10 for the maturity of technologies as they develop. Right, I'm going to move us on to international matters now. And John, I'm going to just point to you initially, because I think early on in this conversation, you were sort of alluding to, yes, the CFD is fantastic, but actually we're still going to need other markets, and there's other sort of projects and opportunities. And I wonder if perhaps you can get us started a little bit on where you see big international markets for yourselves, and also are there sort of perhaps what we can call niche markets where you're working with sort of island communities who maybe are paying for expensive diesel today or something. And in the back of my mind, I've got some of the discussions we've had in different guises where we sort of said, well, your technology, it can fit in a container, so it's actually quite exportable. So perhaps you could touch on that as well.
Sure, Steve. Yeah, no, thank you. Let's start with we call it the plug and play concept. So we can flat pack our turbine into 4 shipping containers and transport that anywhere in the world. So you've kind of got an instant power station. And what's particularly exciting is in sort of some remote communities, they may have access to diesel, which is dirty, noisy, polluting, or no power at all. And what we can do is, so let's use Indonesia as an example. So there's 17,000 islands in Indonesia, and the tidal resource there is vast, it's enormous. And through a combination of tidal with energy storage, you have something which can displace diesel. And that's very, very powerful. The tidal is particularly well suited to storage because you have shorter generation cycles, so 4 to 6 hours compared to solar, which is 12 hours, where you need a larger battery. And you contrast that with wind. It's the unpredictability of wind. We have very large swings and amplitudes, whereas with a tide, it's predictable. So it's just a far more holistic solution. So that's great. And we've coined the phrase a blue energy island. And so an example of that would be one of our projects in Wales, Untitled. So the plan there is to put turbines there in Bardsley Sound. Most of the power would go to the mainland, but there's also the potential to put power into the island. Now, Untitled in Welsh means the island in the currents. So it would be great to see an island, the island in the currents, powered by the current, and supply that predictable, sustainable source of energy. And again, another huge benefit of tidal energy, tidal stream, is that it sits on the seabed, hidden from view, so there's no visual impact on the landscape. So again, that's a huge positive for a lot of coastal communities where they don't want to see the landscape lighted by a nuclear power station or other types of energy. So that's that. So in terms of your question about internationalization, we've recently won funding from the Department of Business, Energy and Industrial Strategy for a feasibility study in Indonesia. That's for a 7 megawatt project in Larantuka. So yeah, very excited about that. We touched upon Canada earlier as well. So our first project there is under construction, with first power due in 2022. And Canada is a huge market. It's got a huge coastline. It's got the largest tidal resource in the world. And just to give you some context here, the Bay of Fundy, which is in Nova Scotia, more water flows in and out of the Bay of Fundy every day than the water which flows down all the rivers in the world combined. So that kind of gives you some context of the potential here. So our project in the Tea Passage at the mouth of the Bay of Fundy, it's for 1.5 megawatts. We're developing that on a phase basis. So phase one, first of all, we're going to put in one turbine in initially. That will then be monitored by the Department of Fisheries and Oceans. And through that first turbine, we actually gain a lot of data in terms of optimizing design for it's a great site, great potential, and Canada's got potential on both the Atlantic coast and Pacific coast. Further afield, huge potential in the US. Also we've talked about Asia, so we've got Indonesia, Japan, and you know, the likes of the potential in Australia, New Zealand, Chile. There are lots of hotspots around the globe, and yeah, the potential is massive. And what's particularly exciting is that we really are at the start of a journey, and there's a whole untapped market of potential here. Yeah. And we see sort of two routes to market. So one is going to be through the addressable market for smaller turbines is vast. So you might have some communities which might want one turbine or two or three or four, but equally there'll be sites with larger potential where we could deploy multiples to 4 megawatts, or as we evolve, build bigger turbines to suit that demand.
Yeah, very good. Thank you, John. And I guess I can immediately see the potential for the sort of the niche markets, if you like, where you're displacing diesel, expensive, dirty, as you say, probably a really strong business case there already for that sort of displacement. For the broader sort of international market piece, do we need to wait for international markets to have their equivalent of CFDs? Are you waiting for subsidy tariffs to turn up in Japan and Indonesia and Canada, or are they already in place?
So they are already in place in Canada, in Nova Scotia. And so we're using that for the Bitty Passage project. So that's really exciting. And there's a lot going on in Nova Scotia. There's a real can-do mindset in Canada, and it's just it's a breath of fresh air. And to see the recent announcement by the UK government after 5 years of no support is just fantastic. So it's great to see. And so in many ways, the UK is catching up with Canada. So Canada's been leading the way there in the revenue support story. Now, as Tidal Stream becomes more mainstream, we see other countries potentially offering revenue support. So, for example, France, again, France has got a great tidal resource. The French government may be looking at revenue support options as well. And collectively, these things are really going to turbocharge the industry. And on the back of the UN COP26 talks in Glasgow in November, there seems to be a real strong political will to make things happen. So Tidal can play a key role in complementing wind and solar, and that's through its uniqueness of its predictability. So that predictability has a value and a benefit associated with it, which can be used alongside wind and solar.
Yeah. Thank you, John. And Philip or Andrew, perhaps I could turn to you. And I suppose I'm thinking about the dual role that your companies have had to adopt, which is sort of one of technology developer, and you've had to develop the projects either through necessity or choice. Do you see that being the same internationally? So, are you going to go international and develop projects, or would you be looking for partnerships, or what would an international strategy be?
I think for me, it's a bit of a horses for courses kind of thing. One of the key emerging markets for Atlantis is France, so just touched upon. And we're 51% shareholders of a company called Normandy Hydroline in Normandy in France. And the project there is to install 4 turbines with a cumulative power output of 12 megawatts, looking in the next few years for that to kind of really kick off. Hopefully get to financial close next year on that. Now that site is going to be really important to us because we're going to be trying to demonstrate some of our new technology. So one of the things we'll be doing will be increasing the rotor size. So it's already been discussed that increases our yield. Also the power output, so moving from 1.5 megawatts to a 3 megawatt generator. We're also going to be looking at using a slightly different way of taking off the power. So at the moment we have 1 cable per turbine. So we have 1 converter on shore putting out the power to grid. On the new mini array of 4 turbines, we're going to be taking a single cable to a subsea hub, and then just 1 cable back to shore. So we'll be operating those turbines at a quasi-fixed frequency in order to do that. And then finally, we'll be looking at installing monopiles instead of gravity-based structures. And the idea there is reduction in costs, but also reduction in some installation costs as well, which is really important when we move to real scale rather than just 4 turbines. So not only is this potential for us to get into the site, more turbines in the water, more learning, but it's also a great chance for us to showcase our new technology and really start to see the cost of energy come down. So that's a really important one for us. And for France in particular, to answer your question, we'll be developing it with Normandy Hydroline. So there'll be local people on the ground, canvassing government for the feed-in tariff, also the kind of the development and the consenting aspects, all kind of handled by Atlantis, but also with our company in France. When it comes to Japan, it's a little bit more, we'll stand back a little bit more, I think, from the actual project development side of things. And that's simply because things are done very, very differently in Japan than they are in UK. And we have to respect that as a kind of technology provider coming in. For the first phase of the project, which is just coming to an end now, we did definitely lead on the installation and we helped with the consenting, provided a lot of information and support there. But moving forwards, I think the way it's going to work is that we'll have a local developer, which at the moment is Kyuden Mirai Energy. They're an offshoot of Kyushu Power, which is a massive power corporation in Japan. And they'll really be wear the developer's hat. and we'll assist them and consult to them, but they will lead the actual development and will supply the turbine technology. And that helps us with a range of things, simply the language, first of all, but more importantly, just the way that the system works in Japan, very, very different to the UK, what can be done and what can't be done, and the way that issues are tackled. And so for Japan in particular, we're definitely going to let our local partners do the actual development side of things and look to be a technology supplier for them. And so I think around the world, I mean, we've got many sites and many locations where we've with various stages of BD. I think it will really depend upon what's necessary and what's required. I think we can offer both services. We can either be a consultant or we can lead. But it's really going to depend on what's required and what's going to give us the best outcome. Some of the other countries we're interested in at the moment or have done work for, we've done some work in Indonesia as well, actually, but also China. We've done some work with some Chinese corporations. In the past, we've been looking at India and done some consultancy for in the regions in India, also the Philippines, South Korea. So there is a whole world out there full of potential. We feel like we're in a pretty good place now to kind of tap into that.
Thank you. Thanks for that. And it's a good reminder, isn't it, that we talked about the cost curve and coming down the cost curve earlier. Of course, it's a global installed capacity that's going to get us down that cost curve. We don't just have to do all of this heavy lifting ourselves from the UK market. Nigel, just looking in the chat, hopefully Philip's question has kind of also answered some of your sort of considerations around what different types of designs are needed for specific locations. So hopefully that's helped out there.
On that point, I mean, in Japan it's quite unique because whereas Pentland Firth, where Maygen is, the water is incredibly fast. In Japan, it's a reasonable amount slower. We're looking at going rather than 5 meters per second top speeds, we look more down at 3 meters per second top speeds. But in Japan, they do have very, very deep sites, so way above the depth of Maygen. And so what we can do at these sites is increase our rotor diameter, thereby increasing our yield that way and still achieve the cost down that we're looking for.
Yeah, very good, very good. I'd like to move us on, if I may, to think about sort of the bigger energy system, just as we sort of move towards a close. And clearly, for Tidal to be considered an ultimate success, it's got to move the dial around net zero. Some recent work indicated that tidal stream could provide around 11% of the UK's electricity mix, so a useful number. Probably at least a couple of nuclear power stations there. I guess my first question is, tidal stream is, whilst it's highly predictable, it does go up and down in generation profile, of course. So how do we overcome that factor? Because for it to be valuable, and Ian in the chat here has put a question to this effect, it has to be stable. It's got to occupy that baseload position that perhaps a nuclear power station would claim to provide. So what sort of solutions is the panel looking at to make sure that we can provide a stable output, even though the tides are not stable, of course?
If it's all right, I'll go quickly on this one before handing on. I mean, you need to be a little bit careful. And if you look at baseload contracts, generally tend to be the cheapest price. So, let's not kid ourselves that baseload is the solution. What it is about having energy on demand. So I think we're in a very, very dynamic energy landscape right now. And, there'll be things that we solve with consumer behavior in terms of demand side responses and things like that. And there'll be generation side. I think one thing that Tidal brings is, of course, predictability. So it marries well with both short and long-term storage, so battery storage, and our O2 project. And our next turbine going to EMEC is going to be playing a part in a future energy system that we're going to demonstrate there with EMEC. So that's going to include both battery storage to allow us to offset generation, where we are now seeing, a characterization in the UK energy market, where ultimately, once we maybe get clear of the short-term gas hiatus, we are seeing renewable generation trend to zero when there's lots of wind in day-ahead trading. And tidal is not linked to climatical conditions. So there'll be times when actually power prices are very high and we're generating. So there's a commercial dynamic there in terms of short-term storage that can be serviced by batteries. And then, of course, there's the major challenge of decarbonising the more difficult areas of industry and energy use that is going to involve different mediums of hydrogen and so forth. And again, a project that we're doing with EMEC, there's an electrolyzer there that's generating hydrogen from tidal stream energy. And of course, the dependability of tidal, in that you can project into the distance how much hydrogen you could be producing and when you're going to be producing, has value there. Just the only other comment I would make in terms of the net zero transition is whatever we end up with, whether it's one nuclear power station's worth of tidal or two nuclear power stations worth of tidal, the major role that we also have to play is a just transition, is that building a UK industry, even at those scales, will generate thousands of jobs, orders of magnitude more than we've been seeing in other renewable energy spaces, where we missed the boat of industrializing at the start. And you can't, and we can see that now, we can't displace manufacturing units. So it struggles to, very difficult to displace entrenched manufacturing once it's made those investments. So I think, let's not forget that a net zero transition has to be a just transition in terms of generating economic opportunities and new industrial base. And that's something that tidal has an extremely important role to play, I would argue.
Brilliant. Andrew, some really great points there. Thank you. We should remind ourselves of the locations of tidal stream development, often in parts of the country that don't have much in the way of other industries. So bringing these sorts of engineering careers to those parts of the country, hugely important. Eileen, can I turn to you, because I know that EMEC are not just doing wave, not just doing tidal, but you're also doing a huge amount of hydrogen and bringing those technologies together. Can you say a little bit about what you've been doing to provide that stable output? And as Andrew said, it's not just base load at £90 a megawatt hour, whatever nuclear is going to be. It's also the on-demand thing. So what's been happening on EMEC with hydrogen?
Yeah, I'll try and do the short version of the story, where Orkney has fantastic renewable resources, but it did not have the grid capacity to match. So since 2013, Orkney's been generating more than 100% of its electricity demand from renewables. And so the way we decided to address that, rather than waiting for upgrades, was to look at different ways to store and use renewables, which started us on our hydrogen path. In 2016, we installed an electrolyzer at our tidal test site, and in 2017, we did a world first of producing green hydrogen from tidal energy. We also have a community wind turbine adjacent. So that turbine was being constrained because of the lack of grid capacity. And so that then turned into a project integrating both wind and tide to produce hydrogen. And that then it kickstarted kind of leading a hydrogen economy in Orkney. There's a whole ecosystem where we're looking at using hydrogen to decarbonise aviation, maritime decarbonisation, even distilling. So that's been really exciting. But most relevant to tidal, I think, is the fact that we are now also in the process of installing an Invinity vanadium flow battery to the site as well. And the difference that's going to make, it's a heavy duty industrial type battery, so that it can deal with the cyclical nature of tidal peaks and troughs, and ultimately smoothing that base load type approach. So that's quite exciting, because that means that we can actually optimize the hydrogen production at the site, because we'll have the battery storage there. And what we're aiming for is being able to produce green hydrogen constantly from the site. The storage element, as Andrew's already covered, is important in itself. But I think when we look at that bigger energy systems piece, there's all sorts of interesting roles there that tidal can play.
Yeah. Thank you. Some great stuff going on there. Thank you. I'm being told that we are running out of time, so I'm going to move to a wrap up. And I think what I'd like to do is just ask each of you sort of, I guess, given that we started this saying, well, the CFD is this seminal moment for the industry, it's rebooted us, it's going to put us back at the front of the pack. Hopefully it's going to have some of that sort of renewed rigor and can-do attitude that John was saying he's seeing in Canada. Can we get that back in the UK here? So in the coming year, what is it that, can you give me, perhaps each of the panelists can give me one thing that you want to see the industry do? What would a successful 2022 look like for Tidal? What's the key milestone, perhaps, for yourselves from your company's perspective? Let me start with John, and we'll go around the table. Sorry, John, to put you on the spot.
Thanks for that, Steve. So I was just about to come in on the previous question, actually. So just to give you a great example of net zero. So our Around the Mara project in Isla is great. So we're looking to put tidal turbines on the seabed there, and the aim would be to provide power to local distilleries. So what you could see is whiskey distilled by the tide, and that'd be a great thing to see. And there's a great push to try and decarbonize whiskey. So I thought I'd just drop that in there. So in terms of the new question to the wrap up, what would be a successful marker for us in 2022? So one would be the installation of our first turbine in Canada. So that would be a landmark moment, which would be transformational for Nova, but also I think for Canada as well. So that's one thing. Two would be the expansion of the Shetland tidal array. So we added the 4th turbine, and we're looking to add the 5th and 6th in 2022 as well. We obviously would want to advance our other projects, and probably Indonesia is a key market for us. I think there's a huge amount of momentum behind Tidal at the minute, and the announcement this year by the government and CFD, it really just feels as if we're at a crucial point. So it would be good to see other countries following a similar path, and I think that's probably a summary of where Nova's at.
Thank you. Thanks, John. And whiskey from Tidal, we'll look out for that one next year as well. Philip, can I ask you for perhaps what your sort of milestone will be to measure success next year?
Well, I think 2022 is going to be a really exciting year for Atlantis, especially off the back of this CFD announcement. So we'll be certainly submitting a bid for that CFD. I think one of the key things for us next year is maybe France following suit. So maybe France coming to a feed-in tariff or some kind of CFD or some kind of similar mechanism for power. That'd be a really great thing to see. For us personally, I think developing that Normandy project in France is really big, and getting towards financial close by the end of next year will be a really good marker for us. I think in Japan, there is a lot of momentum in Japan. It's really captured the minds of the Japanese people and the government. And so I'd be very disappointed if we didn't see further developments there next year. I think what the likeliest thing is that we'll upgrade the turbine we've got right now to make it more of a commercial unit. I think hopefully that will happen sometime early next year. So we hope to have some good news to move into the year with. I think other kind of projects we're looking at, we're actually looking to do some consultancy work on the offshore space in Fundy. So I think that would be a great thing for us to win some part of. And then I think on the back of the success of the Japanese project, and this success is, we're talking about 97% availability for this turbine, so it's massive. We're really hopeful that some of the other BD opportunities that we've got in Asia, like South Korea or Philippines or Indonesia, maybe India or China, will kind of springboard off the back of that. So yeah, we see 2022 as just being a fantastic year for Atlantis.
Thank you. Strong international angle there too. Andrew, I'll come to you next.
Yeah, I think probably along the same sort of lines. We will hopefully see CFD awards. Now, I don't think, we don't underestimate, we're really at the start here, not a finish. Winning a CFD is not a success story. Delivering a successful CFD project is the success story. So we certainly hope that we'll be able to secure an opportunity that will allow us to demonstrate both a commercial and a technical blueprint success story for commercial tidal stream energy. that we can replicate not just in the UK, but overseas. And I think, linking to that will be this vision, a little bit like what Eileen was saying to start with. We really want the UK government to create that longer term vision that will allow us to continue and grow the amount of investment that we can put into projects and the supply chain here in the UK. And ultimately, we would like to see that vision being created by other policymakers around the world, be that in Indonesia, Canada, or Japan, or hopefully as many of them as possible, because this is all about getting megawatts and clean energy into the system as quickly as possible.
Yeah, brilliant. Thank you. And Eileen, finally, can I ask you for your sort of milestone for next year?
Oh, wow. Less of a specific milestone and more a general tidal renaissance is how I would like to put it. Strengthened UK position. Exporting is really exciting, but getting that domestic market nailed down is really important. And there's positive steps being made. And I think building on that is really quite exciting for the year ahead. And then my favourite, getting metal wet, seeing more going into the water.
Yeah, brilliant. Thank you. Fully agree with that. I was telling a journalist last week that I'm hopeful this is the start of a golden decade for Tidal, and it really feels like that at the moment. I'm afraid we must draw to a close. So I'd like to really thank all of the panelists for giving up your time and your tremendous insights into making such a good discussion. I've really enjoyed it. It's been great to have this discussion. Thank you very much for those of you who have been online. Really appreciate your questions for those that have contributed. For those that we haven't got around to, we'll put some written answers in the Q&A just after we wind up here. And just a reminder, everyone who's registered will get a link. You get the opportunity to either listen again or tune in for the first time. Please feel free to share that link with your colleagues. I will leave it there. Thanks so much again for your time, tremendous insights. Best of luck with the CFD as well. Really exciting times. So I'm really excited for what's ahead. Thanks so much indeed, and have a great seasonal break when you get there. Thanks a lot.
Thank you.